So who am I? My name is Mateusz Pusty. I am a Unity developer at Robot Gentleman. I worked on 60 parsecs. I'm also an organizer of Poznań Unity user group meetings. And I'm also an organizer of PGG Jam All Play Accessibility, a game jam that focuses to improve the awareness about accessibility issues in game dev. We've made the 60 parsecs. 60 parsecs is an atomic space adventure game where you have 60 seconds to collect resources, to collect your crewmates, to collect your items, food, stuff like that, and jump into the ship because the nuke is coming onto your space station and you want to survive. So you jump into the ship, the nuke explodes, it throws you out 60 parsecs into the space where you try to survive and find a way to live your life. So who is this talk for? It's for everybody that wants to learn about writing editor scripts. It's also for developers that know basics of Unity and wants to extend their skill set. And it's for people who just want to know something more about Unity Editor. It is not for the masters of Unity editor scriptings, because you probably already know this stuff, but if you're here, you're welcome to correct me. So, on the agenda, we have introduction to editor scripting, some very basic stuff that you can do in Unity Editor to extend its set of options you can do. We will talk about immediate GUI, the tool that is used for making most of the assets currently. We will also talk about UIElements. This is the new thing that Unity have developed for the latest version. I will also give you some tips and tricks, and we will also look through some more information you can read to extend your knowledge after this talk. So, introduction to editor scripting. Basically, what's editor scripting? Editor scripting is a way to allow you to develop your games easier, quicker, and probably better. It's quote direct from Unity. You can use editor scripting to make your life easier for your game designers or even yourself. With a small amount of code, you can automate some of the more tedious aspects of using the inspector to configure your behaviors and provide visual feedback on configuration changes. The very basic thing to dive right into the meat is Unity attributes. Probably you heard already about them. Basically, when you have a component on your inspector and you use public accessor to your variables, then you can see this variable inside the Unity inspector. You probably already knew that. You can also add the attributes above these variables to make the behavior in the inspector differently. So for example, we have hidden inspector that makes our variable not visible on our window. We have serialized field that will allow us to see the private variables, range attribute that will produce this neat slider that's clamped between the values of 0 and 5. We have serialized field multiline 10, which will give us this neat text area where we can type some more text that will be visible instead of just single line for text. We also can serialize our own classes in inspector, just basic plain C# classes. We need to put the attribute serializable on top of them, and then we can use every other attribute inside our classes, just like we can do it in inspector. And to see that class, we just simply put this serialized class anywhere in our code that's either inspector or scriptable object. We can also use attributes to produce some many items that we can click and make to our Unity to invoke some code. So this attribute menu item, which where you need to put a path to your menu item, will invoke our custom menu entry function. There is also a thing in Unity that is very powerful, and it can be used in many ways, also in runtime, but I usually use it as well for Unity editors. It is Scriptable object. These are files that you can create and code them. Basically, Scriptable objects are assets that can store data. They're data aggregators. They're not mono behaviors, so you cannot attach them to your game objects, but you can store them in your project view. You can use them to transfer some data between scenes because the data is persistent. And they won't reset when you exit play mode, so if you make any changes in play mode inside them, this data will stay just like you finished typing it. And the only thing you need to remember about them is that the data won't persist in your built game if you exit the game and re-enter it again. So how to create a scriptable object? Basically use an attribute. Use an attribute create asset many on the class that derives from scriptable object. And this is it. This is basically how we create scriptable object. We have some data here, first and second value. And we can use these values later in our production. It looks like this. We have a scriptable object that's created through this many entry. We have our scriptable object then created in our asset files. And if we click on it, we can see in inspector the first and second value that we just defined. Another thing you can do that's very basic and useful is onValidate. It's a method that you can use like on enable or on update in Unity. It allows you to check mono behaviors and scriptable object for some data validation. For example, if our first value on our scriptable object could not be higher than second value, we can check this in onValidate function and display some debug log. This is a code for it. As you can see, we have onValidate, we have the if that checks our condition, and we produce an error. Another thing that is very useful for me, especially if you have a large data sets in your game, like we have in 60 parsecs, you can create your custom icons for scriptable objects or your even monobehavior scripts. If you click on any script in Inspector, in your project view, then you can choose this icon on the inspector, and it will produce this drop-down where you can select one of the icons that already exist, or select other and provide your own icon that your graphics or you have created. I've created, for our example, scriptable object, a simple pink square with Comic Sans scriptable object written on it. So I will show an example in Unity Editor on how we can use it. This example will be a simple notepad that allows us to write some notes in Editor. And basically, I have created here a scriptable object that holds a note. As you can see, it has this nice diamond icon. And if we look in the code, it's simply a method, a class that derives from scriptable object. There is new note, note button, create new note. We have note stored here, and we have a public accessor for this property. And if I want to create another note, I can simply do it like this, and new note. And that's it. I have a note. I can write something here. Hello, digital dragons. All right. So let's talk about immediate GUI, because this is the biggest part currently in editing assets. Almost all assets are using it. But before we do, I need to talk about a little bit about serialization, how Unity serializes things. Basically, Unity serialized data into YAML. This is a derivative from YAML and markup language. And Unity serialized only some types of files, so you need to be sure that all the data you want to store in your scriptable object or on the behaviors is serializable. It is possible to edit these YAML files. These are the .prefab, .scene, .assets directly in your text editor of choice. It is sometimes useful. I remember when I had external asset that was referencing directly to assemblies of the scripts. And when this asset was moved to another assembly, everything broke. So I just edited the YAML files that were data that this asset was storing, changed the assembly name, and everything started working again. So it is useful to know that you have this possibility. Another thing you need to know is that Unity serialized objects using asset GUIs and local IDs that are translated to instance IDs for runtime usage. So asset GUID is basically the ID of asset in your project, and local ID is, for example, ID of a component inside that asset. And in runtime, they're translated to instances, so you cannot use the GUIDs or local IDs that you have stored from your editor to find something in your builded game. This is the example of a YAML file. The data here is basically what kind of an object it is. So this value means that it's monoscript. This is something strange in Unity because it's called monobehavior, but this is the data of our scriptable object. But basically, both scriptable object and monobehaviors are derivatives for monoscript, so it's okay. This is the file ID, this local ID. And here we have a script file that's basically the script we have created that tells Unity what script is used for this object. And this is the asset GUID of that script. You can also see here the first and second value that we have created in our example, and all other values that are provided by Unity. The good thing is that we can access those values and modify them at our leisure. So we can do it through immediate GUI. Immediate GUI stands for immediate GUI, immediate mode GUI, and it's a legacy GUI system that some of you may remember. It was something that was used in older versions of Unity that was mostly replaced by the 4.6 update with current UI system that is used in runtime. But as I said, in Editor, it's practically the thing that everybody uses. And this is an example of the GUI code. As it is immediate GUI, the lines here are executed even more than once a frame. And every box, every button, every label is recreated every time we go through this code. So the box is created. It produces this neat box with the label imGUI example. We can provide the position and dimensions of this box. We have a button that, if it's clicked, sets was pressed to true, and a label that prints if this button was or wasn't pressed. We have a lot of classes that we can use inside immediate GUI. Basically, there are GUI, GUI layout, Editor GUI, and Editor GUI layout. And the difference is that you can use these ones in your runtime code, but it's not recommended because it's very legacy stuff. And these ones can be used inside Editor. It's very important because you cannot use Editor code inside your runtime code. If you do this, the compiler will give you an error during the compilation that there is some Editor code. But you can use GUI and GUI layout inside your Editor-only code if you want to. And all of these methods produce the same thing. Both produce test label, the same coordinates. And we can also use some helpful classes like Editor GUI utility, application utility, and styles that basically are methods and functions that Unity already provided for us to make our work with Editor a little bit easier. So let's do something fun, and let's create a custom editor for our scriptable object. So we use a class that derives from editor, and we use an attribute custom editor type of scriptable object example. This will tell Unity that we are currently editing this object, if we click on it. And I will present you two methods of doing the same thing and talk to you about pros and cons. The first is direct method, I call it. And first we need to cast our scriptable object example from target. Target is a property available in editor class to get our scriptable object. Then, inside the methods on Inspector GUI, we can draw our label. We start monitoring our code for changes. Then we are showing integer fields for our first and second value, assigning the data from these integer fields to our scriptable object. We are also displaying some information for our designers, for example, that they can't use higher numbers than second value in first value. And when we've stopped looking for changes and there was some change, we are telling Unity that it should update its realization. This is the direct method that operates directly on the data from the object, but we can also, and it produces something like this, but we can also use property method that operates directly on the serialized data that we've seen in YAML file. And we do it through creating serialized properties, finding these properties from serialized object. It's like the target, but the serialized version of it. We look for them through names. And then, on Inspector GUI, we need to invoke serialized object update to tell Unity to update if our object if any changes were made, and apply modify properties on the end to apply our changes. And we use property field to display the first and second value property. So the advantages of the direct method are that it gives you more control on how your editor looks, and you can implement more complex behaviors in your editors. But it's usually a little bit more work. You don't have support for undoing your work, and it doesn't allow you to take usage of property drawers and built-in attributes, because if you display the int field, it's always only an int field. But if you use a property method, Unity handles most of this stuff automatically, so we just tell Unity that there is a property, and Unity will know what type of property it is and what type of the field should be displayed. It also will take for the account the attributes you have put on your variables. You don't need to reinvent the wheel thanks to that. And the and works. So that's also cool. The cons is that you need to find references to the serialized fields by strings. That might be a little bit tricky sometimes if you change the name and forget to add formerly serialized as attribute, because your editor might start producing errors because there is no such field. And there is no other way to add custom behavior to the property field than creating custom property drawer, which is a little bit more work normally, but can give you a large benefits, and we will talk about it in a moment. If you want, you can look at the source code that I will provide to see how I achieved the little bit prettier version of the scriptable object that produces this nice help box with error sign. So we also can create custom windows. Custom windows are created almost exactly like editors. We just use editor window as our base class, and we create public method for opening this window. We give it a path to find it. We use this code to find the window and show it on this position. And In GUI, we just basically do the same stuff we did in Editor. We can use the same methods, the same properties, etc., etc. And we can do something like this, like a window that finds all scriptable object examples. And we will also come back for it later. There are a lot of methods to show the window that produce a little bit different types of windows. I recommend you check it out because they can also make your life easier. We can also create custom property drawers. Basically, what is a custom property drawer is a drawer that will be used anywhere in Unity for your own class. So I have a class that's serializable, that has an ID and a scriptable object example object. And then I have the monobehavior that has variables of the custom property type. I can create custom property drawer that, again, derives from property drawer and has correct attribute, that will display the label for it and these both property fields. I did some calculations here in one line. And this will produce a look like this. This is very useful because you don't need to implement your editor for every monobehavior that you want to have your custom property looking like this. Just implement property drawer, and it will be used automatically by Unity. And if you are also using property fields for all your other editors, it will also work there. Another thing you can do is editing assets. Editing assets, like in our window example, is very powerful thing to do from your Unity editor because you can correct some mistakes in a matter of seconds than going tediously through all assets that your designers have created. And we can do this like that. We have a method called findAssets. This method is invoked when we press the button find assets. It uses the assets database finds assets method, and this string value here is basically anything you can put in the search box in your project view. And you can use the T to find the object of this type. You can use L to find object that has labels. You can just put the name of the object and find all objects that have this name. This method returns the list of asset GUIs, which are the GUIs we've talked about previously. And then you can go through these GUIs, get the asset path for every of these assets, and load these assets as scriptable object example. And I'm adding them to the list that holds them. Then in fix assets, I'm using this editor utility display dialog method to display this "Are you sure?" message. Then I'm invoking find assets to make sure that all assets are found. And for every of these assets, I'm creating a new serialized object so I can operate on the serialized values directly. I'm invoking the update. I'm finding the property first and second value. And if the first value is larger than second value, then I'm assigning the second value to the first value. I'm also listing which assets were fixed, and then applying these properties without undo, because there can be a lot of assets, and then undo may be problematic. So let's go to Unity. I have created here this Notepad editor window that displays a assets. I can press open. I have this window to open file. Then I can go to examples, open the first story, and I can have the text from the first story. I can also save assets. I can save the asset directly. And how have I achieved that? Basically, what I did was here. I've created this scriptable object for holding the Notepad editor data. I'm using here something I'm calling the scriptable object singleton pattern. This is actually a pretty nice thing to do for your editor windows because you don't always want to share your scriptable object that stores data for your windows through your repository because there might be some user preferences that your designers have set. And this bit of code looks for the Notepad editor data in our project, loads it if it finds it, and if not, it creates new Notepad editor data instance and asset at this path. And I'm then sure that this asset is present in the project. Then I have serialized field current node that holds the node we are currently editing. I also have the current text that displays the text in our editor. I have a save method that basically updates the string value of the node property. I have save as that does the same thing but also creates a new asset and asks for the path. And I have open method that opens this asset and sets current node for my node editor data. The editor itself looks like this. I have a method to open the window. I have some serialized properties and object defined. In onEnable, I'm getting the Notepad editor data instance, so I'm sure that this file exists then. I'm creating the serialized object from Notepad editor data to operate on serialized data. And I'm finding the properties, setting some initial stuff. Then in onGUI, I'm just drawing this horizontal group for buttons and label. And then I'm drawing the property field with given rect for our text edit. And this produces this nice editor for our nodes. But Unity decided that they want to change things. And they have brought the UIElements. This is a new thing that they have created for the UI editor. And UIElements are currently an experimental feature that is scheduled to replace both the editor and runtime GUI. The editor is already partially ported to the UIElements. The internal Unity methods and internal Unity teams are working on porting this. And since 2019.1, we can use it as well in our own code. And in 2020, there is the schedule to release it for runtime GUI that the player sees when they play our game as well. And UIElements are basically the old school web design principles implemented in Unity. We have an UXML file that is used to define the structure of our UI. You can think of it about like an HTML file. We have the USS file, Unity style sheet. It's one-to-one, almost exactly like CSS with smaller amount of features. And uQueries that are the C# equivalent for jQueries that we could use in web design. And if anybody is interested, it is based on Flexbox integration called Yoga. And we also have in Unity some debugging tools that are basically the developer modes from web browsers. The most important thing is that it's the retained GUI mode system. So the elements are not constantly recreated. We can find them by their IDs and names and stuff like that. And as I said, 2019.1 is the version to go. but there are some mistakes in documentations. There are methods that are not existing in code, and they are existing in documentation, and vice versa. You can create an UIElements example through UIElements Editor Window Creator. It automatically creates your working editor window with C#, UXML, and USS class. And after creating it, the XML file can look like this. I have added 2 labels and a button for this example. I've also added some styling for the labels, the test class that's here. I'm not sure why I called it test. And the press button that's here, just like in CSS. I'm adding some colors, some sizes, stuff like that. And in our C# class, in onEnable, I am getting a root visual element. This is the element that is basically the beginning for our editor. I'm importing the visual elements from the UXML class file, and I'm importing the style sheet using our asset database methods. Then I am cloning this tree and adding it to my root. I'm also adding the style sheet file, and I'm assigning, after finding it through the query, I'm looking for name, press button. I'm assigning onPress button clicked method to the event that is triggered when the button is clicked. And this is simply debug log. The window looks like this. You can do pretty neat stuff with it, but unfortunately not everything. And I have also created this notepad editor in UIElements. That's basically the same editor we've seen previously, but now it's created entirely through the UIElements. So I have my XML file. Each of these labels, buttons, and stuff is called visual element. So I can create the visual element that holds them all. I'm calling it top view. I'm creating a label, save as, and open button. I'm giving them their own names. I'm also using ImGUI container because I was trying to use the bind method that is in documentation but doesn't work in my version. So I've decided to show you that you can also include the immediate GUI code in your UIElements classes. So if you're porting an asset, you can find it very useful to not having the need to re-implement everything at once. The CSS file just stylizes this XML. And here is a useful thing. I'm telling the top view to be treated horizontally instead of default value that makes all of the elements added vertically. And in my editor window, the simple editor window that we've used in GUI, I am in onEnable getting the instance of my notepad editor data. I'm loading everything I need to load. I'm adding the XML layout. I'm adding to ImGUI container drawNodeArea method that does immediate GUI stuff. I'm adding the save as, and open methods to the buttons. And basically, I have a working thing that's almost the same as the ImGUI version. Some tips and tricks. First thing that's not exactly a tips and trick, but you should do it every time, is to separate your editor code from runtime. Because as I said, When you create your editor code, it cannot be bundled into your executables. Unity won't allow it, so you need to use if Unity editor macros where you put your editor code, or you can put all of the editor code inside editor folders anywhere in the editor, in your game, in your project, and then these files won't be treated and included to build. It is also required if you want to use assembly definitions to store your script, because assembly definitions cannot share the editor and runtime code. Something very basic, but I've noticed that a lot of people don't know about it, so I thought, why not? I include it. If you click this menu icon here on your inspector, you can switch your inspector from normal to debug view. That will display the private variables. It will display the content of your components or scriptable objects without any styling that you're doing. So this might be useful for your use cases to debug some data. In debug view, you can also press Alt and left mouse button on any of the fields, and then you will see how Unity is calling the files, the variables inside their script. So our scriptable object has this first and second value exactly how we named it. You can also use inline property, full property paths, so you don't need to get first texture settings and then filter mode. You can go for that directly. And if you want to find examples on how to do things, I recommend to look through Unity C# reference that's available on GitHub. It was released last GDC, not last, year before GDC. And it's very useful, but if you don't want to go to GitHub all the time, you can just use something like .pig to decompile the code. You can also use nameof if you can, because it's sometimes not accessible because, for example, you're using a real version of .NET that doesn't have it. But if you can use nameof to not use direct string references. Singleton SO, I've talked already about it. And here we have some noteworthy materials and assets. These are the talks I recommend you to watch. They're all the talks from Unite. The talk about UIElements is a very nice one. They also show you some more advanced stuff you can do in UIElements. The scriptable object talks are very good if you want to base your architecture on scriptable object, so you don't store data in mono behaviors. You can use it for everything, actually. And if you want to create some nice tools for your scene view, like a transform tool that spawns particles every time you press an arrow, the talk from Unite Berlin will be excellent for you. There is also an asset called Odin. Odin is Inspector and Serializer. It's available on Asset Store. It's basically a very big tool with custom inspectors, editors, attributes, stuff like that you can use in your own project. But if you don't want to pay them because you don't have the money, for example, but it's not that expensive, then you can go to GitHub. They've released the serializer itself for free, and you can use the knowledge that you've learned on this presentation to create your own inspectors for their serializer. Their serializer is great because it serializes interfaces, it serializes the dictionaries that Unity doesn't, so it might be something for you. To sum up, you can use built-in attributes from some basic styling. Scriptable objects are very cool, and I recommend you use them. YAML is how Unity serializes stuff. You can create custom editors, windows, property drawers for your attributes, custom attributes. You can create a lot of stuff that is helpful for you to create some cool tools. And it's worth to dive into UIElements, because even if you're not interested in creating your custom tools, then probably it will be something good to learn before the runtime comes and Unity tells you that is the way to go with UI. This is the link for this talk. If you want to download it, there's a project, there's the presentation itself on my GitHub. I will wait for a second if there are anybody who wants to take a picture. Okay, and do you have any questions?
Do you have any questions? No? It's too late.
All right.
Everybody are exhausted.
All right, so if you don't want to ask a question directly on the forum, I will be here for a few minutes later. And just to sum up, okay?
Are you using your custom behavior on a play or pause button to get a better pipeline to, for example, build some scripts or objects when you are starting to play a game to not to going through, for example, the whole scenes like many when you are going to test, for example, level X, for example, 10, to when some things are setting, for example, in fast scene,
mostly
how you deal with the persistent data which should be existing in each scene or playing scene.
So basically, persistent data in 60 parsecs, we are using scriptable object to hold it. So they're great for holding persistent data. We have methods that resets them if we want to reset this data. But creating assets for on play and on exit, it might be good for you, but remember that you can only use it in editor through the stuff I showed you, because this code won't work in your build. So remember that you will probably need to use instantiate and normal editor and normal Unity engine code. But you can create your code on play. You can hook up to these methods on pause and changing the application states to use some methods for creating assets in your game.
Okay, thank you.
Right.
Thank you. More questions? No. So thank you a lot.
Okay, can I have a slide for a second again?
Yeah.
Can I have this for a second again? So I also want to tell you that we are hiring. We are looking for a senior Unity developer. If you want to join our team and wear these cool top hats, then send your CV on this mail. And that's all for me. Thanks. And we'll see you on the party.
Thank you.